Alright, welcome to our lesson today on representative relations. So today we will talk about how to present different kinds of relations and understand what they actually mean. So let's just jump right into it. The most common type of relation you might have seen is, say, a family tree. Right? So we have mom and dad at the top, and then they gave birth to you and let's say your sister. And then if your sister married your brother-in-law, then they have a nephew. Right? Or they will have a kid who will be your nephew or your niece. Right? So a family tree is a very simple representation of a relation. And in math, this is very, very important because oftentimes there's many things that we want to relate to together in math. Right? So now the question is, how can we represent those kind of relations numerically? Right? So in those cases, we will start from the beginning. Right? So let's say we have a couple of fruits here. We got an apple or two apples, a blueberry, looks like a tomato to be honest, a banana, and a cherry. So how can we represent the fruit to their color? So here's what we can do. We can first use a table. We can say on the left we have fruits and on the right we have color. Right? Just a very simple relationship. So let's just do down the middle-ish. So if we have, say, fruit, we have an apple here. We actually have two apples. So apple and apple. We have blueberry, we got cherry, and we got banana. Right? So the simplest way to represent something is use a table. So we know that apple, as we can see, has a color red. It also has a color green. Right? Blueberry, as the name suggests, is blue. Cherries are red, and bananas are yellow. So right here, this is an easy way we can represent a relationship. Right? We have fruits in one column, colors in another column. Right? So to two different columns with the same row being one relationship. Right? And we can also represent that with an arrows diagram as well. On the left, we have apples, blueberries, got cherries, and we got bananas. Right? And next we have the colors. So we have a red, we got a green, we got a blue, and we got a yellow. And then we'll put them into circles. And now to use the arrows diagram, we just point it out, right? So apple relates to the color red. Oops. Relates to the color red. It also relates to the color green. Blueberry relates to blue. Cherry also relates to red. And banana just goes straight for yellow. Right? So here's what the arrow diagram is. Once again, we're listing out all the possibilities. And then we're pointing arrow to what it is the most related to. Right? So apple could be red or green. Right? Blueberry goes straight to blue. Cherry goes straight to red. So as you can see, it doesn't really matter how many relations we have. We can relate as many things as we want to. And lastly, of course, banana just gets its own treatment with yellow. And yeah, so that's pretty much arrow diagrams and tables. So we're listing all the possibilities out and then connecting them to their corresponding results. So with that being said, here's another way that we can represent such relations. This is probably the most common method you will see in use, the social media, all that kind of stuff. And this is called a bar graph. And as you can see, it will always have labels, which, well, I kind of forgot earlier, right? So it will always have, first of all, a title. Right, so this title tells us exactly what we're looking at. So the mean height of different dogs, or the average height of different dogs. Next, we have the labels. This right here, this says dog breed. So which means that all those values at the bottom of the graph tells us different dog breeds. So we got Chihuahuas, got Corgis, and Golden Retrievers. And on the left here now, this label is telling us the height in meters, which means that those numbers right here means height in meters. And in order to read this graph, we just pick a category, right? So we pick a category at the bottom of the graph. So let's take Chihuahuas, for example, and we look at the very top of this graph, right? The top of this bar. So right here, the top of the bar of the Chihuahua goes to 20 meters, which means the mean height of Chihuahuas is 20 meters. Actually, that's my bet. It's probably 20 centimeters. A 20 meters Chihuahua sounds absolutely horrifying. So it'll be centimeters. Okay. There we go. That's a much better scale here. Is that right? 20 centimeters? It's around... Yeah, that sounds about right. Right, so we look at the top of this bar right here, which is the number 20. And of course, we don't really know what 20 is. It could be 20 anything, right? But we look at the scale, we look at the legend here, and it's telling us it's 20 centimeters. So from this bar graph, we know that Chihuahuas have an average height of 20 centimeters. Right? And with similar logic, we can look at Corgis now, right? Looking at the Corgis category, so we could look at this green bar right here, we can kind of trace it to somewhere in between 20 and 40, right? Since it's dead in the middle, we can just say that, oh, look at this bar graph. the average height of a corgi is 30 centimeters. And of course, our biggest boy, we got the golden retriever here. Okay, so we're looking at the golden retriever bar, which is the blue bar right here. This top of this bar goes to 60 centimeters. So the mean height of a golden retriever is 60 centimeters. So that's how we read the bar graph. And lastly, here's another relation. So this is very close to what a function looks like, which we'll cover in the next few lessons. We are looking at two boxes here. So English words, with a box, has this number of letters, two natural numbers. Which means that, let's just take a random English word, say English, and has this number of letters. How many letters does English have? It has 7 letters, which means that English would then relate to the word or the number 7. Right? We're looking for natural numbers here. So let's take another word, for example. Let's take mouse. Right? Mouse has 5 letters, so it relates to the number 5. Right? So this is another way we can represent relations. We have something of interest here, as we can put it that way. And we are looking at this relation. So it has this number of letters. And we represent that as the natural numbers. So the number of letters as a numerical number. And the way we can write this, so let's take another word here. Calculator. I'm just looking at the stuff around me right now. Calculator. How many letters does our calculator have? 10. So now in order to write relations in ordered pairs, right, we put them into brackets. So for example, we have for English and the number 7 here, we can just do English, comma 7. Right? So that's one ordered pair. The next pair is mouse, comma 5. And lastly, calculator, comma 10. Right? And all of that will be put in a square bracket. Right? And this right here is what we call an ordered pair set. So just quickly label. So those are ordered pairs. Okay? So again, ordered pairs are just like a quick way or like a nice clean way for us to just quickly visualize what the relation is. So similarly, we can use the same ordered pairs for the dogs. Right? So with the dogs, we have Chihuahua, comma 20. We got Corgi, comma 30. And we got Golden Retrievers, comma 60. So again, we are just representing all those bar graphs information in nice clean ways as ordered pairs. Okay? Oh, and of course, we close everything up with a big square bracket and separate them with commas. Alright, so that's pretty much it, or in terms of understanding relations. Alright, so this lesson is all about finding out the relationship between two different things and then understand how we can describe such relations. So with that being said, let's do a practice question. So pause the video here, try those out yourself, and we'll go over them in a bit. Alright, I hope you all have some time to pause the video and try those questions out yourself. Alright, so the first one, describe the following relation and represent it as ordered pairs. So right here, we have coin and value in a nice little table. So as all we can see here, pennies, when they existed, they were 1 cent. And nickels got 5 cents, dimes, 10 cents, yada, 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 right? In order to write them out as ordered pairs, all we have to do is, starting with pennies, we got penny. We separate with a comma with 0.01, and that's our first ordered pair. And we'll repeat that for all of them. So we got nickel. Right, just like that. Right? So this would be all the ordered pairs of this relation. Right? So once again, this relation tells us the value of each of the Canadian coins. And by putting them in ordered pair, we can quickly just look at all the relations in one go. Okay, here's the next one. So a digital clock displays the 0 to 9 with 2 different squares. Right? You can see it as like an 8 shape. And by lighting up different segments of the squares, we can represent every single number from 0 to 9. Right? So as this example shows, in order to represent the number 2, it will light up this part, this part, this part, this part, and this part. And right there, as you can see, we made a number 2 with the 8, or it was a 2 squares. Right? And the question is asking us to find the relations and put them in ordered pairs with the digit that's shown with a comma, followed by the number of segments that's lit up. Right? So in the case of the number 2, it will be 2, comma 5. Right? Because we're showing the number 2, and it takes us 5 segments, so 1, 2, 3, 4, 5, to show the number 2. So that's what the question is asking us. And first, we can list them all out, right? So with the number 1, right, we can use the table here. So we have the number, and we have the different segments that we need. So number, segments. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And we'll have to write this a bit smaller or shrink it down a bit in order to fit our answer in. Right, so starting with number 1, in order to represent 1 on a digital clock, we covered those 2 segments. Right, that gives us 1. So we take 2 segments. It was number 2, as we know, it's 5 segments, as the example is shown. With 3 here, we'll need this segment, this segment, this segment, this segment, this segment. And from that, we can see the number 3. So it takes us 5 segments. Okay, with number 4, it'll be this one, this one, this one, and this one. Okay, that's number 4, takes 4 segments. Very convenient. Number 5, got 1, 2, 3, 4, and 5. Okay, that's how we make number 5. 5 segments, also very nice. With 6, 2, 3, 4, 5, 6. Look at that. 6 segments for number 6. Okay, to make the 7 and to unfortunately break this trend, 1, 2, 3. 3 segments to make the number 7. 8, this is the fun one. This is where everything gets used, right? If we color in every single segment, we get the number 8, which is 7 segments. With 9, similar to 6, right? We have the first square here, this one and this one, giving us number 9, which is 6 segments. And lastly, 0. Pretty much every single segment except for the middle one gets us a nice fat 0 in the middle. So 6 segments. Right, so this is the relation between the two. So number versus how many segments it will need to light this up. So now to write them as ordered pairs now, we just copy and paste, right? So we have 1, 2 for the first one. And just like that. Right? So this is the order of pairs of the number that will be shown and how many segments it will take to show us that number. Okay, so now for the last question, each arrow represents is the parent of. So which means that if you're looking at those 2 dots by themselves, this dot right here is the parent of this dot. So this person right here is a parent of this person. Right? So this is what this unconventional graph or unconventional diagram is telling us. So let's see. How many children are shown here? So now in order to be considered a children on this graph, you will be at the end of this arrow here. Right? Because once again, this person is the parent of this person, which means that this person is the child of this person. So which means that we can look at this one right here, this one, this one, this one, this one, and this one. So those 6 dots are representing children because they're on the receiving end of the association is a parent of. Right? So this tells us we have 6 children here. Okay, how many parents are shown? So with the parents, this one's a lot more straightforward, right? So the arrow refers to is the parent of. So this person is a parent of those 3 kids. This person is a parent of this 1 kid. This person and this person, they're the parents of those 2 kids. Right? Which means that those 4 people are also parents or are parents because they are on the starting end of is the parent of. Of course, lastly with the grandparents. So with grandparents, we know it's the parent of a parent. So if this person is a parent of this person, then this person is the parent of this person and a grandparent of this person. Right? Which means that there's only 2 grandparents that is possible to have this association. Right, and that's pretty much it. So again, this lesson is all about finding relations and figuring out a way to represent them so that's nice for us to see. The most common way is to use ordered pairs. This is how we can quickly look at examples. Right, so from the next lesson, we'll actually put those into practice and start looking more and more onto the functions themselves. So with that being said, keep practicing and stay hydrated.